All right, let's get to it. So, welcome everybody to today's webinar. My name is Robert French. I'm a applications engineer. I'm out of the San Diego office for GoEngineer. I'm kind of our CAM specialist in the SoCal area. I also do quite a few other things, SolidWorks, 3D printing, trying to get into simulation, been trying to take some certs recently, so I try to have a little bit of a foot in everything, but definitely my specialty would be CAM and SolidWorks generally. Yeah, and so obviously that's what we're talking about today is SolidWorks CAM and CAMWorks. Doesn't matter what package level you have. That's really the only difference there is SolidWorks CAM is kind of your base included version. If you guys are on SolidWorks 2016 or newer and you're on subscription, paying that maintenance fee to us, then you have access to SolidWorks CAM, the free version, and everything that I'm going to show you today. And then some of you might be in some of the more higher level packages that you pay for, advanced functionality and things like that, and that's what we would call CAMWorks. So same software though, interchangeable, save one file, send it to the other, send it back, all good. Alright, so obviously focusing in on planes and then avoid and contain areas today. So this is basically everything but the toolpath, right? Like how do we control, the limits of our toolpath, where it goes, and things like that. It's kind of all these arbitrary controls on our toolpath. So let's jump into it. So the first thing we're going to talk about is the avoid areas. So these are pretty good for just representing fixturing or the vise you're in. You can kind of see in the example screenshot there. I have a couple kind of clamps I've modeled up, and then a couple additional sketches as well. So going to kind of run you through both scenarios. You can have multiple sketches going on, right? So you can kind of see I have 4 clamps there. You could have 2 big, broad sketches on each side to represent a vise, for instance. You can model up your vise. A lot of those vise manufacturers provide those models as well, so they can be downloaded. Another thing with avoid areas is they have to be given a height. So a 2D sketch isn't enough. A fixture, if we're in assembly mode, which is in the next package up, that's in SolidWorks CAM Professional. We can obviously model those fixtures, but if we're just using sketches in SolidWorks Standard or any package, right, we have to give it a height. We have to suggest, it has some volumetric shape to it rather than just some two-dimensional shape. And then there's additional operation parameters, like if you jump into an operation that you've applied an avoid area to, or even a contain area, there's a couple additional parameters inside the operation that can affect how you interact with that. So let's jump into SolidWorks. And then now we're here in SolidWorks, and we can kind of go over some of this. You can see I have just this pretty simple part here. I've created my setup. I've created 2 features within that. I have a perimeter boss feature. Then I have this internal, or these 2 other rectangular slots that we'll come to eventually. But let's take a look at the sketches on the outside as it pertains to the part perimeter feature. So if I jump over to my operations tab, this contour mill is what's programmed on that part perimeter. I actually saved this how I didn't mean to, so, oh no, I just haven't generated toolpath again. Here we go. So no avoid areas, going around the part, nice and smooth. Oh, and before I forget, feel free to ask questions anytime, guys. I'll answer it if it's relevant. I can get to it quick. If not, you can stick around after, and we can get more in depth. But shout questions at me anytime. There's a question and answers kind of dialog box on the Zoom application. So once again, contour mill going all the way around, and I have these kind of 4 sketches representing, kind of 4 stub nose clamps maybe. So we apply avoid and contains to the operation. So if I right click on this contour mill, that's once again programmed on that perimeter boss feature, we can see on the left hand side of my screen. If I right click that guy, I can go ahead and say, let's add a new avoid area. So very similar kind of identifying method or definition method to creating a feature or doing other tasks within CAMWorks. We can basically select from our sketches or existing faces and loops and things like that. As I look at my part sketches here, I actually don't see the sketch I created. Right? I believe it's sketch number 13 in my SolidWorks tree that I created all 4 of these closed contour sketches in. Well, over in the property manager here, you have a couple options for shape. So we have silhouette, we have a bounding box, right? So that kind of creates an XY bounding box around an irregular shape. And then the last option we have here is multiple. And that's what I'm looking for, because I could draw one individual sketch for each of these avoid areas, but a little bit easier to control and more easier to organize and looks cleaner if I do it all in one sketch. Well, if I do it like that, I'm going to have to choose this multiple icon under shape. Once I do that, sketch 13 pops into my list of available sketches, or allowed sketches. And once I choose that, now I've got them identified. Perfect. That kind of defines my XY areas in terms of my avoid. But once again, we have to set a height. So over here in the property manager, if we continue scrolling down, a couple other options that are included: adding offset to these guys, right? So increasing their XY profile. You can offset, right, with rounded or sharp corners. We also have direction. We have some of the common end conditions we're used to. Typically with this, you'd probably be entering a blind amount, because these clamps just have their own blind arbitrary height. You can go direction 2, identify start points for programming, and then some avoid area options as well, which we'll get to. I'm going to set my height here on these guys. I'm just going to assume they're about a ½ inch tall. You can kind of see the preview on my screen update, kind of a wireframe outline out there, showing you the extents of your avoid area. I'll hit check mark. Now I can regenerate toolpath. I might have done it already. I'm just kind of a OCD about regenerating toolpath whenever I make a change. You can see the toolpath right around those clamp areas, right? Those last two toolpaths, those last two depth of cuts kind of stopped, right? And we have these retract moves that kind of go over them and reset us and go back around. So once again, the avoid areas are contained underneath, right, the particular operation they apply to, right? So underneath that contour mill, now I have avoid area number 3, right? Because I've created a couple of these, deleted them. It keeps iterating in number. But if I wanted to get rid of that, edit that, right? Anything we want to manipulate in the tree there, we can always right-click and hit Edit Definition, right, on just about everything in this tree if we're looking to get into the properties or the nitty-gritty of that. Change the definition of this avoid area, or just delete outright. So once again, like I kind of started this part example, when I first started, I was like, oh, I already had it in there, I didn't want it in there, but this is why I regenerate toolpaths. Notice I just deleted that avoid area. I got to give the software a chance to recalculate. So I'm going to right-click that setup or operation, generate toolpath one more time, and now it doesn't assume the clamps are there anymore, the avoid areas. So, all right, let's jump back into the PowerPoint real quick, keep discussing. Cool. So that was avoid areas. Fixtures, actually, let's jump onto fixtures right now as well. Sorry about that. So I got an assembly going. This is the only way fixturing works within CAMWorks is within an assembly. You have to have independent other part files. It can't just be independent solid bodies. It has to be another part file. And this is only available in the second level up of SOLIDWORKS CAM. You go from SOLIDWORKS CAM Standard, which you all have, to SOLIDWORKS CAM Pro. It's the first place that assembly becomes available. I'm going to jump in and say Manage My Parts here. I got lightweight mode going. Let's jump back and resolve everything. Alright, now we can do our part manager. Because we're in assembly mode, we kind of have to indicate to the software which parts are machined parts, which parts are fixture parts. I've identified this part as a machined part. I can jump in and add definitions in here, feature definitions, that is. So look in the top down there, I'll go ahead and add my part perimeter feature of a boss. And I'll add my 2.5 axis feature, and let's go with a pocket internally here. There's my 2D area. Let's give that pocket a height up to the top of the part. Perfect. And let's start to program these guys. So I'll go ahead and, get some toolpath out for this perimeter feature. I'll just generate operation plan. The contour mill default should be good enough. And we get the toolpath like we expect, just like we saw in part mode a second ago. But now we have these additional clamps, right? We actually have physical models of what we want to see machined, or what we want to avoid, physical models of what we want to not cut into, right? What we need to avoid, right? So it's actually done here in the Operations tab. You want to right-click the setup because your clamping and fixturing changes per setup, so that's kind of why it's organized at this setup area. So on the Operations tab, right-click Setup and Edit Definition. There's an extra tab when we're in assembly mode towards the end here called Fixtures. I can grab that guy. If you have more of them, like I have this one internal to this pocket, and I know that's not how you would ever use a clamp, but it's for example purposes in a moment. But I do want to include that clamp, so if I highlight clamp here in this little window, I can say add all instances, so it automatically would grab every single clamp with the same part number, right, or same part name, and I could say avoid all of those, right? These are where the fixturings are during this setup. I need all of them to be respected and not gouged and cut into. Obviously, it wants to regenerate my toolpath, right? And you're seeing, oh, that's right, I only have the clamp on the one side. But you're seeing some intelligent motion around that clamp, right? Looking internally here at this pocket, if we were to program a rough mill, let's just generate operation plan out for that rectangular pocket, and then let's just generate a rough mill operation. Tool's a little too big to see what it's really doing as it interacts with that clamp. Let's go in and change that so that we can see a little bit more clearly how it behaves with respect to the fixture. So you can see that it essentially does it as a, well, let me double check my heights here. Can you change the lead in, lead outs only for the avoid areas? Yes, you do have some control there. I'll go back to that in a moment. That's a good thing to discuss. Depth of cut here. Let's make sure we're not going too deep. Right, so you can see though, it is getting my point across. I just wanted it to be a little bit clear with a few depths of cut, but essentially what's happening here is we're getting a pure XY avoid on this clamp, right? It doesn't care if it has multiple shelves or heights. It just kind of does a pure XY avoid around it. So something I've been able to do is use multiple contain areas. So I have two sketches here. I have a kind of a rectangular sketch and then this square sketch, which is kind of a simple representation of my clamp here, right? Looking down on the profile of it. You can set one height for the large rectangle and another separate height for the square itself when you do a void area. And you can have kind of different heights. It'll respect each height independently, and you can do a little bit more clever things there. So even if you don't have fixturing, which, once again, when I do my avoid areas, I'm still limited to just extruded shapes. I can't do any kind of curved shapes or anything like that. But if all you have is nice square clamps, then you can not even need fixturing, not even need assembly machining necessarily, and just use a combination of sketches. Let's jump back to the original part file so we can talk about the lead in, lead outs. It's a good question, so I'm happy to go over it. Avoid area, let's reestablish that. I got to go multiple sketch mode. Check mark. I did not set a height on that. There we go. Let's check out our toolpath now. And so your lead in, lead outs, you can't treat them differently for each clamp. They'd have to be the same definition for each clamp, essentially. So you can see we're doing an arc type lead in here, right? And so this would just have to be changed on all of them. So perpendicular, for instance, right? It changes every definition, the original lead in, lead out, and how you are around the clamps or the avoid areas. So additionally, how much are we avoiding those avoid areas? Remember I mentioned there was some stuff within the operation parameters that allows you to control some of this functionality. So under the Advanced tab, there's avoid areas and contain areas, right? So avoid areas, how are we linking between them? Rapiding over, feeding around, feeding over, and then the clearances to each of those, right? So how much do we have to go clear above and clear in X and Y? Right, so we have different options here. Rapid over, we could feed around, right? A little bit slower, but you don't have all these awkward retracts and entries and things like that. Now you don't have to worry about lead in, lead outs maybe as much, or I guess you do maybe because you're still getting kind of a lead in on this side. Just kind of maybe shifts the problem in a way, right? You kind of have you have different criteria to worry about, obviously. And then we have feed over as well, which, I mean, quick, efficient. You just got to worry about the surface finish, perhaps, on the feature, and plunging over here might be not the safest thing to do, right? But you have all these options and considerations, so avoid areas within the operation parameters. Let's jump back to the PowerPoint. All right, keep moving on. So contain areas now. Contain areas are analogous, obviously. There's a lot of similarity, but a few extra, or lack of steps, I should say, right? No height required. We are simply giving an XY contain, right? The tool is just contained within an XY. There's no Z contain involved at all, like there was on avoid areas. So we still have options in the operation parameters. You guys might have seen that a second ago when I was tweaking with the avoid area. And this is just a quick way to program in a lot of ways. Can be quicker than the alternatives. Might seem like an extra step, but in the long run, it just provides a much better organization and workflow for your programming. So let's take a look at contain areas. All right, let's switch over to our funnel part. I've already got some stuff programmed on here. I had a face feature, because we had some extra stock up top here. We had a multi-surface feature, and when I click that, nothing highlights. And if you guys aren't used to multi-surface features, basically every other feature you define in CAMWorks and SOLIDWORKS CAM is, I draw a 2D sketch, and I give it a thickness, right? So it's all like extruded boxes and extruded circles and stuff like that. When it comes to a multi-surface feature, we actually go in and click what surfaces we want to cut. So I could go in and click all the surfaces I'm interested in cutting, and if all I wanted to cut was this internal shape here, I would continue along my path that I'm doing right here, click all those surfaces internally there, and that's all my toolpath would apply to. But I'm going to say all displayed instead. Basically, looking down my end mill here, which is that red arrow and green crosshairs, the green crosshairs are my X and Y, the red arrow is my Z, my end mill coming down. All displayed says cut every single surface you can see here. And that's just a lot easier on me. Sometimes you have 100 surfaces to click to program. It'd be a lot easier to just say cut everything and then come back with an avoid or a contain area, right? And force that part into a zone that you're interested in, right? Avoid all the stuff that you're not interested in. So whether you use a void area to avoid stuff or a contain area to contain it, doesn't really matter too much. It's two sides of the same coin. How would I program a part with staged avoid areas? For example, having clamps on one side of the part, machining half the part, then moving clamps to the other side of the part. Would that involve two separate CAM files? You could do it as two different setups. And sorry to pause on this real quick, but that's a quick, easy answer. So over here, what I would probably end up doing is take this sketch. Let's copy, paste that sketch. Let's go into one. Delete half the clamps. Let's go into the other one. Delete the other half of the clamps. So now I have two different sketches, clamps on one side in one, clamps on the other side in the other. When I'm here in CAMWorks, what I can do is duplicate a setup. Actually, I wouldn't have to duplicate a setup. I can just create another operation. So I'll right-click that perimeter. I'll go and add another contour mill. So now I have two contour mills on the same feature. In this first one, it's only using, the sketch has been updated to only use these on the right? So if we look at the toolpath, it only respects the clamping on the right. And now when I go to the second contour mill, I'll add another avoid area and choose the clamp on the other side. And now I'm doing avoids on this side. So Derek, I hope that answered your question. It's a pretty quick and rough answer, but don't be afraid to duplicate steps, duplicate setups, or, you know, we're doubling up on this a little bit, and there's a lot of extra toolpath going on in here, like we're cutting the Z heights way too much. Like, we only really need this to happen for the last little bit where the clamps are. Don't worry, in the rest of this presentation, I'll tell you how do we get rid of all these additional Z heights? How do I not duplicate all that stuff? So, good question. Sorry to jump around on you guys a little bit. back to the funnel. Remember we were talking about, yeah, no problem, Derek. We were talking about multi-surface features. Rather than clicking 100 surfaces, I'd rather just say cut all the surfaces you can see, and then I'll try to use contain areas to curtail that. If I use configs for fixtures, does CAM respect the config name? Yeah, so you have to have SolidWorks CAM Professional or higher. That's the second package level up. That's the first one you pay for, past standard. If you have configurations going, configurations treat it as if it's almost an entirely different part file, but it's not a different part file, right? So my point with that is that you're basically starting from scratch again. So all your CAM stuff will kind of start from scratch. You can re-identify fixtures in a different way, re-identify your parts in a different way. CAM will allow you to put all your different fixturing, all your different setups, all your different things into one file. And then CAM configurations will allow you to kind of treat it as piecemeal, right? Like, okay, in this setup, I'm only going to use these two things for fixtures. And in this configuration, I'm going to use these two things for fixtures, right? So a CAM configuration here would basically just reset yourself. You see when I do that, I get a blank feature tree. But any other part files and stuff in there, I'm just starting from scratch again. But it's better to contain it in one part file, obviously. Managing multiple part files is painful. Sorry, multi-surface feature, quick way to define it. But if I go and add Toolpath to an all displayed, right? Yeah, James, fixtures are the same thing with configs there. You would just have to go re-identify them. Right? It works exactly the same. Fixtures, you just treat it like another CAM file with new fixturing in it, identify fixturing as is, and go for it. All right. Multi-surface feature, all displayed. So when I look at this area clearance, it's doing all displayed. I already have a face mill up top, right? I don't need this area clearance to machine the material up top. I'm also not thrilled about it going down into this hole at the bottom of my part here. I'd probably rather drill that later than interpolate it with this flat end mill. So there's a couple ways we can deal with this. And like I mentioned, a couple ways to deal with this. Like I mentioned, there's quick ways and there's inefficient ways. One of the inefficient ways here is inside of area clearance. You can actually do what's called rest machining or work in progress. And what that basically says is this toolpath analyzes what's been done before it and only cuts what needs to be cut. But look how long it's taken me to generate toolpath here. And if you have a lot of other operations beforehand, it has to go through and calculate all those other toolpaths and figure out what's been done, what it has to do still. So that can take a long time to program. So instead I'm going to say contain area. And in this case, I'm going to use constant depth loop because we're dealing in constant depth of Z, right, as we come downward in Z. And I can just choose this loop right here. Some things I'll do somewhat often is I'll add just a little bit of offset to that. I don't want the tool to necessarily like stop right on that edge. I want to give it a little bit of wiggle room to just machine that edge and get the finish, right? Get that crisp edge there finished and completely programmed. So watch how much quicker the toolpath generates this time, because I don't have to analyze everything that's been done already, right? I mean, at least, you know, at most half the time to generate the toolpath here from before. And it's contained XY to that area. All right, I have yet another way I could have done this. I'm going to delete the contain area for now, generate some toolpath while I jump back into the PowerPoint. So quick programming in the sense that you don't have to use work in progress, which is a very powerful functionality, very good. Use it when it's necessary, but don't use it when it's not necessary, right? It can take a little bit of programming time and calculation time for your computer. Okay, one more thing on contain areas before we jump back into that funnel part. Contain areas, right? So features have inherent contain areas. Like, why does a toolpath stay where it is without me adding contain areas? Like, where does it think its limits are? So let's jump in and take a look at it. Got our last part here, which I've done a multi-surface feature on again. And I'm just going back and forth. And see how it stays true to the feature. I actually click this top surface and it machines this top surface, right? But if I jump into this pattern project, or even rough mill, contour mill, whatever it might be, in this case, it will be on the, where is it on this guy? Finish tab, we have our limits. We are looking for contain and avoid. Where are you? I probably was right on it earlier. There it is. I was right on it, of course, which is why I couldn't find it. The automatic contain area. Right now it's on all silhouettes, as in all silhouettes of your feature definition. When I click that and kind of rotate my part, you know, looking X, Y downward, we have that kind of automatic contain area. We can also say stock. And since I've added some extra stock all the way around this guy, that's now the contain area, the kind of inherent contain area. If I preview my toolpath, definitely get some stuff I'm not interested in, but just kind of explaining how this functionality works. And then in addition to that, when we say all silhouettes, we mean all silhouettes of all surfaces. You have options like bounding box, once again, which, you know, you can kind of see the graphic previews here. Right, gives an XY kind of box, simple box around everything. But then we also have what is the tool condition. Right now this is on center, as in the center of the tool is allowed to go up to this inherent contain area. So I've changed it back to silhouettes and back to on center, and this is back to square one. But if I go in and I say, hey, the tool is allowed to go past the contain area, and I can even add offsets here, or up to, right? This would be more of a pocket condition, like stay within these edges, stay within the walls, right? But I can do past, for instance. I'm allowing the tool center to go past the silhouette, right? I'm increasing the silhouette, in other words. Tool doesn't go down quite as far as when the stock extents were used, but a little bit more wiggle room for it to spill over. We had another question here real quick. What method would you use to control the waterfall effect? Perfect question here from Garrett, who says, control the waterfall effect that sometimes happens with a toolpath going off the edge of a multi-surface feature. This is literally what I call the waterfall effect right here, right? Spilling off the edge right here. Right? It almost looks like a waterfall, right? So Garrett asked the question at the perfect time. I was ignoring it for a quick sec to get through my thought, but it looks like I answered it as I was going through here. So this is most often one of the culprits, these contain areas, these automatics. So you want tool to go up to center. You also have options like, let's go back to on center, all silhouettes. We also have options such as, let's see if it's in here. Tangent extension. Right? So what I want to happen is I want it to come off the part and really give a good finish there on the edge, but I don't want it to waterfall. Tangent extension can be really good for that. I would just have to increase that a little bit, but you can see it coming off the part now a little bit extra, but continuing along the trend, right, in a tangent way, so it's not waterfalling. Last idea here, hopefully. Nope, z-limits. Let's make this very quick. These are just arbitrary z-limits. So we had contain area, which was kind of limited to x, y. This is our z control. So once again, quicker than the other options. It's better than adding the work in progress and things like that. So if we jump inside this area clearance operation once again, on the advanced tab, I believe, it might be different in here. It is. Let's go to the area clearance tab where it's found in this case. Limits. And a lot of the 2.5 axis operations, it's found on the advanced tab. But here, limits, first cut from top of stock. Well, that's, you know, it sees material up there. That's why it wants to cut up there. So you can offset this using, you know, just these numerical inputs. I'm a big fan of user defined. There's a lot of places in operation parameters that you'll choose this, and then this little icon will appear where you get to go choose a point. I'm going to go choose a vertex. You can choose lines, edges, vertex. I choose right there. And I'm also going to offset that downward, just a little bit. 100 thou down, right? I mean, in all honesty, 1 thou down would be enough, as long as you're below that top surface, right? you're setting an upper Z limit. No toolpath allowed, no cutting toolpath allowed above that point. You'll still have entry methods and plunge methods. But once again, this is a hell of a lot quicker than trying to do work in progress. It's even potentially quicker than contain and avoid areas, depending on the complexity of your shapes and things. Right? So another method of doing, we've done this 3 different ways now of controlling this toolpath. Let's also try about last cut. So I don't like it plunging down into this hole. Same idea here, last cut, user defined, choose a point, kind of rotate in. I don't know if it'll let me choose this edge. See, it puts the point in the center of it, but way up there. So let's maybe just click this bottom edge or bottom vertex, and then we can push it up a little bit, and hit preview, and then move on here in a sec. Right. If anybody sticks around after, I can show you a little bit more on how I would preferably control what's going on down there. But these are all totally approved methods, would totally work fine. Let's jump back. All right, last slide here, guys, and last topics for the days. People just tend to get these a little confused, and they're not perfectly clear about what they do. The rapids, clearance, and feed planes. So rapid is just our absolute, where does it start? Looking at this picture on the left, it's the absolute highest red, which are the red dashed lines, which is our rapids. It's also the retract plane between features. You can see as it transitions from the slot on the back side to the slot on the front side, it takes that rapid plane. Clearance is location before the Z feed begins. It's also where it retracts to between the different cutting heights, and then feed plane is where your feed move finally starts. Let's jump into software real quickly, analyze that on our original part here. It had these slots earlier, right, that we were programming. Now we go look at the rough mill that's cutting that guy. Let's edit him. Rapid plane. A lot of these are defined with respect to existing geometry, so top of stock plus 1 inch. Right, as I increase that value, what we'll see are these kind of 4 peaks up here. The entry and the exit, and then this transition line between the features. That's what we're affecting with rapid. When it comes to clearance plane, that's this plane right here, and there's a couple of them going down because it happens between each Z feed height. Right, it's where it retracts to between the Z feed heights. So as I increase that, right, we're seeing that increase in here. And then lastly, feed plane. This is pretty subtle to see. Kind of have to zoom in and see an actual inlet. So we're doing previous machine depth. Let's try current machine depth. Right, so previous machine depth, the feed was starting all the way at the top, right? Starting all the way where the rapid plane, or not the rapid, but the clearance plane was a moment ago. Now that I set it to previous machine depth, it rapids way further down, and then I can specify this feed distance right here. That's this 30 thou that we see. If I increase that to like 150 thou, obviously we see that increase. All right, if you guys are unaware, this will be recorded and uploaded eventually to our YouTube channel. But if you're curious as you're going through the software to remind yourself what any of this information was, what any of the, Robert told me what rapid, clearance, and feed plane were, but I just forget. At any time you're in operation parameters windows here, go ahead and just jump into the help file at any time. Because what's great about this help file, look at the tab it took me to. It took me to the section of the help file it took me to. NC tab, 2-axis mill operations. That's exactly where I was a moment ago. Guess what I see in here? Rapid plane, clearance plane, feed plane. If there is a text box or option in this window, there is an entry for it in the help file. So anything that you're like, I just wish I knew what that was, wish you just gave me a little bit of info, it's always a click away in the help file. So that's all I officially had for you guys today. This will probably be where I would conclude the webinar and record and what you'll see uploaded. But I am going to show you one little more tip and trick if you guys were interested on that other part file. We can jump over to the funnel here real quick. So we talked about ways to kind of control what's going on down here. So a couple things I'm going to mention here. Let me edit this area clearance real quick and get rid of that Z limit. Regenerate some toolpath here. So remember the way I defined this feature. That's kind of key to this, and another reason why I mentioned using contain areas is a faster way to program, more intelligent way to program. Remember how I defined my feature here. It was a multi-surface feature, all displayed. I didn't click anything. I just said, if a surface is present, go cut it for me. And then obviously I apply some X, Y, and Z restrictions on that. I'm going to teach you guys a little bit of surfacing today. It'll be the easiest surfacing you've ever learned. If you don't know surfacing, if it's intimidating to you at all, you shouldn't be intimidated. It gives you a great addition to your CAM programming, and there's a quick couple easy commands that make it's very foolproof, and you'll have a lot of confidence, I'm sure. I don't want to cut this hole. I want to pretend as if that hole doesn't exist. I don't like going through SOLIDWORKS and creating configurations, and that can be a little complicated. I want to fill that surface. I use the filled surface command. I click the edge. Right now this surface that's filling in that gap, filling in that hole, is a really simple surface. It's a contact surface, as in it just feels the need to make contact with the edges, but not be smooth or continuous. It's just a very straight shape. So might not give you the best toolpath. You want your toolpath to come down nice and arcing and sweeping and continue sweep. You don't want it to go arc, 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 straight line, arc, 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 right? You want continuous. So you can bump up the quality of this guy, tangent or curvature. Curvature is the best quality. Tangent is usually more than enough, 99.9999% of the time, especially when it comes to CAM. So I go with tangent. That guy's filled in, right? That's an infinitely thin surface, though, right? That hole's not filled in. So I could still recognize this hole feature very easily in CAMWorks. But also, what was my multi-surface feature definition? All displayed. This surface is displayed. If I hadn't done it this way, if I had clicked all my individual surfaces, I'd have to go edit my feature definition and click and include that surface in it. But because I said all displayed, it's automatically added. If I go look at my area clearance toolpath, it's automatically respected as well. So using all displayed, filling in some surfaces where there's holes and inconsistencies or non-continuity on some of your multi-surface features. Filled surface can come in, you use all displayed, use a couple of contain and avoid areas. It's one of the quickest, most effective ways to program. So that's all I really got for you guys officially. If anybody wants to hang around, I'll hang around and answer any more specific questions. But thanks for coming, guys, and we'll call it officially there. So, yep, thanks again.